The limit as x approaches 0 of root 2 plus x minus root 2 whole divided by x. Now this involves the evaluation of a limit when there is a radical in the numerator, and in such cases we would have to employ what is called as rationalization technique. So we're going to look at that in this question. Limit as x approaches 0 root 2 plus x minus square root of 2 whole divided by x. So as always, let us put x is equal to 0, and then we get root 2 plus 0 minus root 2 whole divided by 0. So the numerator is root 2 minus root 2, which is 0, and this is also 0, and we end up with the indeterminate form. Now, in order to remove or eliminate the factor or the terms which are leading to this indeterminate form, we can't cancel the terms because of the square root. In such cases, we will resort to what we call as the rationalization technique. Rationalization of surds is a topic you would have studied in the 9th or 10th standard. Anyway, I'm going to revise it here. So now what we are going to do is we are going to rationalize the numerator because the numerator contains the surd or the irrational part. And in rationalization, what we do is we multiply this whole term with its conjugate. So let us assume we have a term root a plus x divided by x, and we want to get rid of this root a in the numerator. What we do is we multiply this numerator by its conjugate, which means root a minus x, and then we also multiply the denominator by the same term. So what we have essentially done is we have introduced the a plus b into a minus b form, which gives us a square minus b square, thereby eliminating the square root term. So this becomes a root a whole square minus x square divided by x into root a minus x. Or we could write this as a minus x square x into root a minus x. So let us employ this technique in our question. The limit as x approaches 0 root 2 plus x minus root 2 whole divided by x. Now we're going to multiply by the conjugate of the numerator, which is root 2 plus x plus root 2 divided by root 2 plus x plus root 2. Now if you notice, there is again this a minus b into a plus b, which means this becomes the limit as x approaches 0. So I'm going to directly write this square minus this square, which means 2 plus x minus 2 whole divided by x times root 2 plus x plus root 2. So the 2 and 2 get cancelled, and I am left with limit as x approaches 0 x divided by x into root 2 plus x plus root 2. So now I can cancel the x's and declare x is not equal to 0, which leaves me with the expression limit as x approaches 0 1 upon root 2 plus x plus root 2. Now I can safely substitute x is equal to 0 here. So I say put x is equal to 0, which implies 1 divided by square root of 2 plus 0 plus root 2, which is 1 plus root 2 plus root 2, which is 1 by 2 root 2. Therefore, we report the final answer as the limit as x approaches 0 square root of 2 plus x minus root 2 whole divided by x is equal to 1 by 2 root 2, and that is the final answer. Now in this question, we have rationalized the numerator. We'll look at another question which is very similar to this, but there we will have to rationalize the denominator. Limit as x approaches 0 x divided by under root a plus x minus under root a minus x. So it's very clear from this that we have to rationalize the denominator part. So let's write down the limit as x approaches 0 x divided by square root of a plus x minus square root of a minus x. So first we try to put x as 0, and then the numerator becomes 0 and the denominator becomes a plus 0 minus a minus 0, which is root a minus root a. So again we end up with the indeterminate form. So now we rationalize the denominator. The limit as x approaches 0 x divided by square root of a plus x minus square root of a minus x. Now we are going to multiply the denominator with the conjugate of this term, which is square root of a plus x plus square root of a minus x, and we'll multiply the same term in the numerator as well. If you notice, the denominator again has the a minus b into a plus b format. That gives us a square minus b square. So this becomes the limit as x approaches 0. And I'm not going to write root a plus x whole square again, because I know when I square this term, I'll get a plus x. So the denominator becomes a plus x minus, notice there is a minus here. So I'm going to get a plus x minus a minus x within bracket. So when I open the brackets, I get a plus x minus a plus x. So this is what I'm going to write here. A plus x minus a plus x. And the numerator becomes x times square root of a plus x plus square root of a minus x. So I can cancel the plus and minus a's, and then this expression is reduced to limit x approaches 0, x into square root of a plus x plus square root of a minus x whole divided by 2x. So I can cancel the x's and declare as x is not equal to 0. So this whole expression is reduced to limit as x approaches 0, square root of a plus x plus square root of a minus x whole divided by 2. So now let's put x is equal to 0, which gives us root a plus 0 plus root a minus 0 whole divided by 2. So the numerator becomes root a plus root a, that is 2 root a divided by 2. We cancel the 2's and then we are left with root a. Therefore, the limit as x approaches 0 of x whole divided by square root of a plus x minus square root of a minus x is equal to root a, and that is the final answer.